Hi, everyone, and welcome to VMworld 2020, and welcome to Virtualize Active Directory the Right Way. My name is Matt Leibowitz. I'm part of VMware's go-to-market team as our professional services team. And with me is Sander and Deji. Go ahead, Sander.
Hi, my name is Sander Berkouwer, and I'm a VMware V expert, joining these fellows from VMware to talk about Active Directory today.
And hello, everyone. My name is Deji Akamalafe. I'm the lead for Microsoft Application Virtualization here at VMware, and I'm glad that you can join us today.
Okay, folks, as you know, we have a standard disclaimer. We are not intending to cover any future products or releases, but if we do, just understand that things may or may not be in final versions going forward. Here's what we're going to cover. We're going to start with the why, and then we're going to talk through how we achieve integrity, how we ensure availability, and how we make Active Directory tamper-proof throughout this session. We're going to start with saying, number one, this is not an Active Directory class. Deji's going to take a couple minutes and talk through some of the basics of Active Directory and how it relates to replication, just because that's important to everything related to Active Directory.
Thank you, Matt. Hello, everybody. As Matt mentioned, this is not an Active Directory class, but in order to contextualize what we're going to be talking about for the rest of this session, let's do a quick intro on how the Active Directory components work together. Active Directory itself uses multi-master replication, where writes originate from one domain controller, except for the read-only domain controller. Schema updates are special, of course. They happen only on the schema master. And each domain controller selects one or more partners they replicate with to form a mesh of a replication topology. There's some additional complexity which we won't get into, but the infrastructure master and the global catalogs require special attention in the replication scheme. Under the hood, the replication flow works like this. It requires 4 distinct elements: the directory services agent GUID, the DSA GUID, which is unique to a domain controller, persistent over the life of that domain controller, and it's used in USN update sequence number to track the domain controllers that's originating an update, a change, or a write. Then there is the invocation ID, which is used by the DSA GUID to identify a copy, an instance of the AD database on that particular domain controller. This can change over time, especially during a restore operation. We also have the update sequence number, which we call the logical clock. This is used by the domain controller to track updates that they send or receive from their partner. It increases per write for every transaction, each domain controller that receives or sends an update. Now there is the timestamp. The timestamp it's used for conflict resolution. The stamp itself is a combination of the version of the object being replicated and the originating time and the originating DSA. So these combined together forms the stamp, and this is what is used as a last resort to resolve any conflict, write or change.
I've made a little animation, and I've put together 2 virtualization hosts running vSphere, of course. And these 2 virtualization hosts run domain controllers. And those domain controllers just happily hum along in their Active Directory sites. And of course, we've got all sorts of computers and users connected to it. And as we allow Active Directory to do its work, what we're seeing is that every domain controller has a unique serial number. And they don't have to be the same. This is just a point in time. They probably won't be the same because domain controllers are added at a later point of view, stuff like that. So it doesn't really matter. We've got a 400 and a 270 here. And in the high watermark table, each domain controller knows the unique serial number for its replication partners. And the unique serial numbers are located in the high watermark table and denoted by the invocation ID. And this is important because every replication partner is denoted with its invocation ID, not its name, not its IP address, not its DSA GUID, but its invocation ID. And what we'll see is that as we create a couple of users, we see the unique serial number for DC1 go up with the same amount of write transactions that are needed. And then we replicate all that over during standard replication. And DC2, of course, performs the same writes because the same objects need to be created. And it also goes and writes into the high watermark table that the last time that it actually replicated with DC1, it saw the USN for 412 for the invocation ID. Now, of course, if I create another object on DC2, what you'll see is as we replicate that over, we got all the same writes, we got all the same updates of the unique serial numbers that you would expect. So this is how that all works under the hood. And as we're talking about the Active Directory replication, and as we're sharing our best practices during this session, then one of the best practices that we really want you to know about is that VMware really likes you to follow the guidelines that Microsoft has. So please do not disable the bridgeable site links option, and please don't configure manual bridgehead servers or manually create replication partnerships and stuff like that, because there's only a small amount of environments where you actually need that. And of course, take care of proper networking and a good Active Directory domain and site design.
Let's talk about why we want to virtualize Active Directory. Starting here, listen, we used to say virtualizing first is the new normal, but let's be honest, it's just normal today. This is what organizations do. It's no longer spooky magic where people don't know how it works. It's fully supported. This is something Microsoft deserves a lot of credit for. They fully support Active Directory running in VMware or any virtual platform. The other thing is Active Directory is really friendly for virtualization. Domain controllers, like you just heard Deji talk about, they're largely interchangeable. They're mostly identical, so they can be quickly and easily changed in and out. So they're just really, their characteristics are very friendly to virtualize. In addition to just the model of it being distributed, multi-master, and having low resource requirements, which we'll touch on a little bit, make it really easy to virtualize. And then lastly, a single domain controller can't utilize the resources that you find in modern servers today, 512 or gigabyte or terabyte of RAM. So you're really just wasting money if you throw that much hardware at a domain. And so that's why that's one of the reasons why folks virtualize. So now Active Directory, critically important, obviously, to every organization. We recommend that you follow Microsoft's best practices for domain controllers, even though it's virtualized. So deploy domain controllers across multiple data centers. Don't make WAN connections for directory services. You can have them in each location. Distribute those important roles, those FSMO roles, onto separate servers. By default, the first domain controller has all the roles. So if you are the admin for Active Directory and vSphere and you've never moved the roles, they're all on the same server. Again, follow Microsoft's best practices here. You can see a link to that. The other thing, you can use vSphere rules. You can use anti-affinity rules so that you can separate virtual machines such that you don't have all your domain controllers running on the same ESXi host. So if there's an outage, they don't all go down at once. And then you can also use host affinity rules so that you always know where a particular domain controller is. For example, the PDC emulator role, which is largely very important for a number of things in Active Directory. Last but not least, should you P2V a domain controller? Only if you want to ruin your weekend, if you hate yourself, if you just want to have a bad day. If you absolutely have to do it, there's a knowledge base article here you can follow, but we strongly recommend you just deploy a new VM, promote it to a domain controller, replicate the database, and you've got a new domain controller. Here's the common objections that all three of us have heard when it comes to virtualizing Active Directory. Timekeeping in virtual machines is hard. Totally agree on that. We're going to spend some time talking about that. Does it deviate from your current or standard build process? Geez, I hope not. I hope your standard build process is to virtualize first, and using templates and virtualization actually helps standardize. Do you need to keep a single domain controller physical to maintain, say, the PDC emulator role in a physical machine? The answer is no. It is very easy to both transfer a FSMO role if you need to, or seize one if that server becomes unresponsive. So there's no reason to keep one physical. Privilege escalation, sit tight, we're going to talk about this. This is making sure that vSphere admins and domain admins do not overlap. And then last but not least, the fear of the stolen VMDK, we've got an answer for this one too. This is when a rogue administrator steals a VMDK and then they have your database. So how we're going to organize this talk is it's really going to come down to Active Directory confidentiality, the integrity of your database, and availability of directory services. All right, so we're going to talk about timekeeping now. I'm going to pass over to Deji. He's going to talk about how important timekeeping is in virtual machines or domain controllers.
Okay, thank you, Matt. We touched briefly on the role of timestamp in arbitrating changes that conflict or originate from multiple domain controllers, maybe at the same time. Time is of very critical importance in an Active Directory infrastructure. The default time synchronization leverages W32 time, where devices synchronize time with the nearest domain controllers. And the domain controllers in turn synchronize their time with their PDC emulator. The PDC emulators in a child domain synchronizes time with the PDC emulator at the root of the forest. W32 time limits phase corrections. If your time skews too much, it won't be reconciled. After 48 hours, forward or backward, W32 time doesn't correct that time. This is controlled by two different registry settings or GPO, and the reference for that is here. Another critical use for time in AD is Kerberos authentication and, of course, authorization. Kerberos 5 is used for authenticating and authorizing in AD, and it's used for the TGT from domain controllers to authenticate other resources. When the time is optimal, then conflict resolution in an Active Directory environment is kosher. It's all good. When it's off, for example, by more than 5 minutes, Kerberos authentication fails. Passwords don't get synchronized, people can log in, and many other things fail in that environment. So let's do a quick demonstration of what we are talking about here. There's two domain controllers. There are two domain controllers here, virtualized, of course, DC1 and DC2. DC1 is synchronizing with time with the host, and DC2 is also synchronizing time with the host. There are the devices and there are the users behind the devices. These devices synchronize time with the domain controllers as well. Now, as long as everything is correct, times are in sync, everybody is happy. If there were an error, a time clock error on host A, for example, that error will be propagated up to DC1, which then will be propagated up to the client and everybody that's authenticating against that domain controller. For example, on DC1, say user 1 is sitting behind a device that received a wrong time from DC1. When that user tries to authenticate, and if that authentication request goes to DC2, for example, DC2 will not be able to process that because the time is off. This is one of the reasons why we are going to spend time, yes, talking about time synchronization in a virtualized Active Directory environment. And this is important because it's one of the most common issues administrators encounter when virtualizing domain controllers. Should you disable time sync between a domain controller and an ESX host? The answer is yes. In the past, we used to by default synchronize a VM's clock, regardless of whether it's a domain controller, a Windows VM, or whatever, to the host. That created issues. We stopped doing that. As you can see in this screen here, we stopped checking that box that says synchronize time with guest, with host. You would expect that this will prevent, or this would solve the issue of the VM getting time from the host. Of course, it doesn't. There are some operations in vSphere that will cause the VMware tools to actually reset, adjust a VM's clock. For example, if you suspend a VM or if you migrate it using vMotion, take a snapshot, you restart the VMware tools or you reboot the domain controllers, it will, even though this checkbox is unchecked, it will take time from the host. This is described in one of the most popular KBs on VMware.com, KB 1189. Please consult it. It's important to know that you can do everything listed in KB 1189, which we will discuss in a subsequent slide, and your VM can still receive time from a host. So please pay attention as we describe this in more details and demonstrate the effect. Our recommendation for avoiding this is simple. Let AD do the time hierarchy and the time correction for a domain joined VM. If it's a Windows box, it's joined to a domain, let it take time from the domain hierarchy. To avoid the corner case we mentioned in KB 1189, there are advanced configuration options that you can apply to a VM. You can apply to the template that you use for deploying your Windows VM, so that when you perform those virtual operations like vMotion, like a restart, like a suspend, the VMware tools will never adjust the clock on that VM. These are the configurations that you can add. And you could also do this when you're using the VMware vRealize Orchestrator. There's a plugin for that. If you are upgrading to vSphere 7.0.u1, we actually make this very simple, so you don't have to hard code these advanced settings anymore. There's a checkbox in here, synchronize at startup and resume. This checkbox does exactly what we just described with the advanced configuration options. So a very good use case for moving quickly to vSphere 7.0 update 1. Let's talk more about strategies for proper time synchronization. Ensure that the clock on all your ESX hosts are correct. Always sync your ESX host to an external NTP source or a reliable NTP source. We recommend that you probably want to disable DRS for your PDC emulator. Again, we will describe why that's important later. My colleague already mentioned to use VM and host affinity and anti-affinity rules. You could use the affinity rules to pin a PDC to a specific host. This helps you ensure that you know exactly where the PDC emulator is at any given point in time. Now, it's important for us to mention that even though we said the VMware tools adjust a VM's clock whenever you perform some virtual operations, it's important to know that the VMware tools does not correct time backwards. If the time skews forward and you move the VM to a good host, we will not be able to move the VM's clock backward unless you apply these advanced configuration options to that VM. Also, please note, if you had already applied the settings we mentioned earlier in KB 1189, these settings here will not take effect at all. All right, let's do a short demo of the time correction and effect that we just mentioned.
Okay, so we're in our lab environment. We've got two virtual machines here. They're both on a host with good time. And our plan is, you can see they both have the correct time. Because they're on a host with good time, their time matches. So they are both at the same time. Our plan is to move them to a host with bad time. And this is what we call Usain Bolt time, meaning it's very fast. The host time is very quick. And what we've done is on the two virtual machines, on one of them, we have configured those advanced features that Deji just spoke about, and that will prevent the time from changing when we do perform a vMotion, and on the other one we did not. So let's see what happens. We're just going to do a basic vMotion. What you're going to see here is what we mentioned earlier. There's a new warning here in vSphere 7. It doesn't stop the migration, but it does show you that there is clock drift and just gives you a warning and says these hosts are out of sync more than 5 minutes. Won't stop the migration, but it does want to warn you. And then our plan here is we're just going to kick off the migration, and we're going to look at the console of both virtual machines. And what you're going to see, if you look at the virtual machine on the top here, before I even had a chance to finish, it is switched to 1015, so the clock has changed on this. Now, thankfully, no virtual machines were harmed in the making of this demo. Those are not domain controllers, but if they were, bad things will happen. So what are we going to do now? We're going to perform a vMotion back to the host with good time. And as you heard Deji mention, normally the clock does not reverse during a vMotion. It won't correct in reverse, but we've added the advanced settings that will allow that to happen as well. So what should we expect to happen after this vMotion is complete? The host or the virtual machine that has the wrong time should adjust back on its own to the proper time. And you can see right on cue it has. So this is just a quick demo to show you that what can happen when you perform vMotion and other operations on a virtual machine, and why timekeeping is critical for domain controllers.
Another successful live demo. Right. Thank you, Deji. Now, what we're seeing is that all those moving parts inside Active Directory actually play a role in replication. And when all those moving parts fail, then what you see is that we've got big problems. And one of those big problems is a unique serial number, USN rollback. And let me explain with one of our other favorite animations. So we still have DC1 and DC2 on the left and on the right. And we still have the invocation IDs, the highest committed unique serial numbers, and the up-to-dateness vector. So if I create, 10 more users, what we'll see is that the USNs are updated. And when we replicate, we will see that those users are updated, and the up-to-dateness vector is actually updated to 110. Right there on the top right corner. When we create a snapshot, then that's not a problem. We just create a snapshot, and now we create some more users, or we create some more things. So for instance, we create 10 more users. The USN changes to 120. We replicate, and actually DC2 knows that the last time it replicated, the up-to-dateness vector was 120. Now, what if we reverted back the snapshot on that domain controller? So now what we're seeing is that the USN was 120. We now set it back to 110. And as we replicate that 110 and we create some other users, DC2 still knows it's 120 or should be 120. We create 10 more users, we replicate, and then what we're seeing is that domain controller 2 actually says, you know what, we're not going to do that. If I were to allow this, then I would basically allow Thanos to click and make those 10 users vanish. Instead, what we're seeing, and this is something that has been in place with Active Directory since Windows Server 2003, is that the DC2 actually actively blocks those changes. It will actually turn it back on DC1. All the replication partners will turn that back on DC1 and make sure that no changes replicate in, because this is a sure enough way to get to lose your Active Directory integrity. So what are the best practices for preventing USN rollbacks? How do you get out of this mess? Well, the best thing to do is not get into it. And there's two main practices that I would suggest. And the first one is to monitor Active Directory replication. And the second one is to never, ever revert to a snapshot of a domain controller.
Okay, so we see now what USN rollback can do and the dangers there, but now we want to talk about making virtualizing Active Directory safer with a new feature called VM Generation ID. Microsoft introduced this new feature as part of Windows Server 2012 and beyond, and it's a special 128-bit value that's exposed to the virtual machine from the host. So that generation ID is communicated through a special driver within Windows, not the VMware tools, and it allows this generation ID safety feature to work. In order to make it work, you have to use vSphere 5 Update 2 or later, which I'm hopeful most watching this are already on. It's exposed in the VMX file, actually, in the advanced configurations. If you look, you'll see vm.genid or .genidx, and it is added to all VMs configured as Windows Server 2012 or later. So this is a key point, though. If you've got a Windows Server 2019 VM, but you've got it configured as something other than Windows Server 2019 or 2012, even though the guest will support it, the host will not expose this generation ID. So it's important to make sure you've got your guests configured correctly. Now, this generation ID value is tracked in a new attribute in Active Directory for the domain controller object called MSDS-generation ID. Importantly, that attribute is not replicated to other domain controllers. You'll see why that's important in a second. Anytime the generation ID is changed, that kicks off these virtual machine safety features. That's the first line defense against USN rollback that Sandra just spoke about. Reverting a snapshot, a number of other operations will trigger this and kick off the safety features. So a little bit more on sort of how it works. These safeguards allow a domain controller to be reverted from a snapshot or restored from a backup to continue to function as a functioning member of the directory service. So what will happen is the generation ID value is evaluated during the boot sequence before any Active Directory updates are committed to the local copy of the database on that domain controller. So after you perform a reversion of a snapshot or a restore, when you boot up, Active Directory triggers generation ID to compare the value between the gen ID for that VM and the value stored in the local copy of the Active Directory database, the MSDS generation ID. That's why that database, that's why that value doesn't replicate. It needs to stay with that VM. If those values are different, it's pretty simple. It effectively dumps the RID pool, it invalidates the one that's there, and generates a new invocation ID for that local Active Directory database. And that allows two things to happen. Number one, new changes can be committed to the database and synchronized. It also can provide the ability to get changes that were lost during this restore or reversion period, the period in which the domain controller was not replicating with the rest of the environment. We'll touch a little bit on what can happen if this goes wrong and how you can get out of, or how you can get into DSRM jail and how to get out of it a little bit later when we talk about cloning virtual machines. But let's quickly just do a demonstration of how this looks. Similar to our other ones, we've got DC1 and DC2. Generation ID you can see is 001 for both, or for the DC1, and the starting USN is 101. So we're gonna take a snapshot, right? Nothing wrong yet, nothing bad has happened. We're gonna create a user one. It's gonna use USN 101 and invocation ID A. It's gonna replicate that to DC02. DC02 is gonna say, I accept this transaction. No reason not to. Now, this administrator is going to revert the snapshot. So that kicks off the safety feature. So you notice now generation ID has changed. And so it's going to kick off the process of evaluating and comparing the value to the local copy in Active Directory. It's going to see that it's different. It's going to accept that new generation ID value, dump the RID pool, and create a new invocation ID. Hope everyone's still with me. Now we're going to create another user, user 2. I'm going to reuse USN 101 because I don't know any different. I've been reverted from a snapshot, but I'm going to use invocation ID B, the new value that I have, and I'm going to replicate that over to DC2. DC2 is going to accept that transaction because it knows that the safety feature is kicked in. Not only is it going to do that, it's going to say, I noticed you don't have user 1 anymore, so I'm going to give you back user 1. Now, in the previous example where we saw the Thanos snap and everything sort of went to dust, with generation ID, Windows Server 2012, 2016, and 2019, everything is awesome. No issues with safety. Let's see Deji dancing in the background. No issues with USN rollback. Safety is preserved and the domain controller continues to function as a domain controller. Now what we're going to do now is jump into our demo environment and show you what this looks like. Okay, so we're back in our lab environment. We've got another 2 VMs. This time we have 2 domain controllers, DC1 and DC2. And we're going to start by showing you that they are in sync and they are replicating. So you can see our list of users here for DC, for one of the domain controllers. Let's go over here. We're going to make sure that, so they're exactly the same. We are in sync with our 2 domain controllers. And so now what we're going to do, like we just talked about before, we're going to take a snapshot. So we're going to go and just within the regular vSphere console, We're not going to do anything fancy. We're going to take a snapshot of DC2, and then we'll show you what happens when we delete that snapshot, or when we revert, I should say. Okay, so we're going to let this snapshot proceed. Okay, so our snapshot is just about done. Once that is finished, we're going to do a few operations within the DC02. Okay, so we're done. So we are on DC02. First thing we're going to do, we're going to create a folder. That big folder, you'll see why that makes sense in a second, but when we revert the snapshot, that folder should disappear. Now I'm going to dare Deji to delete all the users to start with A. So Deji, I dare you to do it. This is a career limiting move, but he's a brave man and he did it. All those users are gone. So let's go check and make sure that replication is working. We'll just pop on over. We can kick off replication manually to make sure that the replication works. And, in a normal environment, this would happen anyway, but for a demo, we want to go quick. Let's check our other host, DC01. Let's refresh this. And what we expect to see is all the A users are gone, and they are. So Deji's career limiting move has now completed. So what we're going to do now is revert the snapshot. Now, if this was anything other than, we're using 2019, if this were a previous version of Windows, 2008 or something, this would be really bad. But Deji, let's show them what happens here. Reverting the snapshot. So first things first, what we're going to see, we're probably going to have to reconnect to the remote console session here because reverting the snapshot will kill that. But that's okay. We can reconnect that. Okay, so we're reconnected. First thing you can see, the big folder is gone. That's what we'd expect because we reverted the snapshot. The A users are back. So if everything worked, if VM generation ID kicked in, when Deji refreshes that folder, the A users should disappear. Okay, so it's woken up and you can see that the A users are gone, the B users are back, and replication is working. Generation ID kicked in. It made sure that the safety features kicked in so that DC2 made sure that it got the deletions that previously were there, that previously were made, and both domain controllers are working and talking to each other again.
Thanks, Matt. Wasn't that beautiful? I'm still standing, career ending move, and I'm still here. Okay, now that was good, but let's be honest. There are situations where what we just did won't really do much for you. You are only protected by VM generation ID in certain circumstances. Domain controllers that run anything below Windows Server 2012, this doesn't work, as you saw in previous slides. The virtual machine hardware itself has to be hardware 7 or above, or if it's below, we won't surface VM generation ID. If you take a VMDK and reattach it to a VM, we won't change the VM generation ID inside the VMX file. And if you do a NAS or SAN rollback of a storage, we won't be aware of that, so we won't change the VM generation ID. If we don't change the VM generation ID and we don't surface it to the OS, no safety takes place. Okay. If you don't have VMware tools installed, we also won't be able to surface that properly. Now, that was beautiful, right? But should you actually be doing domain controller snapshots? We recommend that you don't. If your backup software does, that's fine, image level, yeah. But just right clicking and taking snapshots, we ask you to not do that. Remember, snapshots are not backup. It's even easier for you to deploy in plain VM, promote it to a domain controller and transfer or sys role, whatever it is that you want to do, other than snapshot. In general, it's very unlikely that you will frequently use the feature, but it's there if you need it.
We don't do anything with snapshots, but what if you want to live dangerously? And what if you wanted to do more with that VM generation ID? Well, that's interesting because there is something that we can do with the VM generation ID beyond the safeguards. And that is domain controller cloning. And domain controller cloning is a welcome side effect of domain controller safeguards, because as we now can detect when a domain controller is reverted from a snapshot, we can also detect when it is cloned. Not when it's hot cloned, because we don't do that on vSphere, but when it is cloned. And now we can deploy domain controllers really fast. So think about an organization with about 700 or 800 domain controllers, and these are all ransomware. Then they have to get a domain controller from Ghana flown into England to get their domain controller back, for instance. And you now have to create all those domain controllers. How do you do that? Well, the safest and fastest way to do that, and safest, I say safest because you want to do it with all the agents and the backup software and all that stuff on it, because that will create that continuity across all your domain controllers, is with domain controller cloning. Now there's a sequence to it, and you have to prepare the source domain controller for cloning, then shut it down, then clone it using the hypervisor, because that's essential, because the VM generation it is in the hypervisor. It's not in on the storage level. And then we power on the new domain controller and it will actually come back. So as you can see, the demo DC2 is not one of the FSMO role holders, which is important to know. That's why Deji ran netdom query FSMO. And also we have the DC clone preparation script right here. So on line 5, we actually add this demo DC2 to the clonable domain controllers group, because that's how Active Directory admins stay in control of cloning. Then we make sure that on line 9, that all the apps and services that are installed are actually clonable. And of course we checked, and we checked VMware tools too, so that's safe. Line 17 allows us to create the DC clone config file, and we do stuff with IP addresses and a new name and stuff like that. And of course, then we force replication on line 26 through 31. And we did have a shutdown.exe right there, but we're going to do that manually. So Deji, take it away, buddy.
And one of the things we can do after the script is kicked off in that clonable domain controllers group and make sure that our domain controller that we're cloning is in that group, because otherwise it won't work, as Sander pointed out earlier. And there we go, we've got it.
Yeah, and of course, if you're done cloning, I think it's a pretty good idea to actually remove the domain controller from the group and not let it linger, because that might prove pretty awesome one day, but not in terms of your job security.
Okay, so here, this is the DC clone config file with all the attributes we had in the script, including the host name we're giving it and all the IP information. And now what's left to do, boys, but shut her down. So after the shutdown is complete, we're going to just kick off a normal cloning, right, within the vSphere client. Nothing special, no fancy tricks, right, guys?
Now all that we have to do is actually clone demo DC2. So we're going to clone it to a new virtual machine, and we're going to name it aptly DC4, because that's its new host name. And of course, we won't do any of the customization things, because that will mess up our demo, and that's not something we want today. And yeah, we're powering it on because that saves us time. Well, let's do it, Deji.
All right, and now the clone will proceed.
So it's done, and it's going to power on automatically, Deji, remember? And let's wait to see it start up.
And what should we expect to see, Sander, as this thing boots?
We are expecting to see the good blue screens. So not the bad blue screens that we normally see on domain controllers. Do we really? But we would see a domain controller starting, and then it will message us that it is actually cloning. But of course, it does its all the Windows stuff before that, before it actually starts.
Yeah, and it does read the XML file to get the configuration settings that it's supposed to apply to the new domain controller.
Of course. You didn't do all that stuff in your script for nothing, Deji. See? And it's domain controller cloning.
And in the meantime, DC02 is still down, but at this point, we can power DC02 on, but we won't do that for now. So let's go look in DC01. we should have an object for DC04 right now.
There it is.
That, gentlemen, is a successful clone.
Of a
Yep.
domain controller.
Let's
Good job.
continue. And look, it's up. So Deji, we can sign in, I guess, because of course everything just works in our demos.
Yeah, because we sacrificed the right chicken to
Yep,
the right
we
God.
sacrificed the chickens.
Chickens plural.
Yep.
So let's bring up Active Directory users' computers for this new functioning domain controller. And let's have some fun, right, Deji?
Yes. What does the domain controller do if it cannot domain control? So let's do a quick user creation. Let me just create an object and verify that it can actually replicate to the other domain controllers.
This is the way I usually make users. I just slam my fingers on the keyboard until I've got something that resembles a username, and then we go. All right, so what should we expect to happen right now, Sander? We've created a user on DC4.
Yeah, so we created a user on DC4, and you can actually see that Active Directory user computers was targeted at demo DC4. And we should actually see, if we start up demo DC2, we should see the user replicated there, but we can probably already see it on DC1.
That's right.
DC04 is able to replicate the newly created user object to DC01. So we know that this clone is a successful operation using VM generation ID domain controller cloning feature. All right, we just did a domain controller clone. Why would you want to do that? There's so many reasons why you would want to do that. Maybe there is a security breach. Your domain controllers were owned. You had a template or a copy of your domain controller somewhere that you want to restore. That's one use case. It is not something that you want to do every day. You want to deploy multiple domain controllers at a location or a new greenfield implementation. Those are the use cases. Remember, vSphere 5.0 update 2 is the minimum version of vSphere where VM generation ID is actually surfaced. And the guest operating system, as we mentioned before, must be 2012 or up for security reasons and to avoid your vSphere admin or a rogue admin just cloning your domain controllers anytime they want. Please always leave the clonable domain controllers security group empty. If the domain controller, if the reference DC is not in that group, it cannot be cloned. Always validate that all the software are clonable. Whichever is not clonable, exclude them. If you're using a Windows backup, when you finish taking a clone, always delete the backup history and take a new one. If you clone a domain controller to a template, always remember the tombstone lifespan for that version of Windows. If you don't prepare the domain controller clone, the reference domain controller properly, the resultant domain controller clone will not succeed. Okay, what are the effects of DC safety on disaster recovery? If you define disaster recovery as a complete catastrophic failure of a site where you have all your domain controllers and other resources, and they are not available, that is a disaster event where all your domain controllers are gone. How do you recover? Hopefully you've listened to us and you have other domain controllers somewhere, or you're using something like a VMware Site Recovery Manager. Remember the DC safety logic. The VM will be required to discard its identity. It will discard its read pool because when you restore that VM, the VM generation ID changes. Now, what if that domain controller is your read master, the one who is supposed to give the new domain controller a new set of read pools? You have a chicken and egg situation there. Of course, you can always seize that role if you have another domain controller alive. Now, the best way to avoid a situation of catastrophic failure and you can recover from, even with a VM generation ID feature, always have multiple domain controllers in multiple different sites. replicate the read master and the PDC emulator especially to the DR site, maybe as a warm site or even a cold site. When you bring up your domain controllers in a disaster recovery scenario, you may have to reboot the read master multiple times because normally the directory services won't start because it's not able to replicate to another domain controller, perform the initial replication that we mentioned earlier. You will have to either use a PowerShell command, restart service ntds-force, or you may have to just keep rebooting it multiple times before the service starts. Well, you could just wait for a long time. Well, in a disaster recovery event, that's the last thing you want to do. So please be conscious of this, of the effect of VM generation ID on disaster event.
Okay, so we're going to touch on some sizing considerations now, what I consider to be the most boring part because domain controllers are easy to virtualize. But let's look at, CPU, memory, storage, etc. CPU, pretty straightforward. What Microsoft says, one CPU is good for 10,000 users. Anything more than that, my recommendation, start with 2 vCPUs and scale up. CPUs are very powerful these days, especially modern CPUs, so that's probably going to be enough for you, but scale up is needed. Now, when it comes to memory, think of Active Directory like any other database server. And one thing database servers do really well is they cache the database in RAM so that subsequent reads come out of RAM instead of disk, so read performance is increased. Well, Active Directory does the same thing. If you monitor in Performance Monitor, there's a counter called database cache hit percentage. If you monitor that for the LSAS process, what you'll be able to see is the amount of time it's using that cache. If the cache hit rate is really low, that means memory is probably not high enough for it to cache the database in memory, and your DC could benefit from more RAM. Network, there's nothing to it. VMXNet 3, standard like any other virtual machine. And then storage, there's no real special storage performance requirements. You just need to give it enough space for the directory database, the AD database, plus room to grow, the sysvol share, and plus any operating system files and any other software you have on there, like backup or management agents. Really not that complex. But DNS is complex, right, Deji?
Yes, it is, and it's one of the most critical part of Active Directory functionality. It's very delicate. The clients and domain controllers reference objects in an Active Directory infrastructure by name or GUID. The internal processes also use DNS. We mentioned the initial replication conundrum, where a DC is required to perform an initial outbound replication with another domain controller in that infrastructure. And if it's not able to do that, it can't start advertising itself as a domain controller. This is documented in Microsoft KB referenced here. There's a way to disable this check. We highly recommend that you don't do that. Here is an example of what I just mentioned. DC1 is starting up. The first thing it does is initialize its TCP IP stack. What's my IP address? What's my DNS address? If you notice, this server is pointing to itself as its own DNS server. It is required to sync with another DC. So it says, I must sync with a DC2. DNS, please give me DC2. DNS service comes back and say, yeah, you need to start me first. Okay, please start. And DNS server says, oh, I can't start because you need to sync first. DNS service is not able to start, and AD is not able to initialize. You end up in a state where that DC is not performing the role it's supposed to perform in that infrastructure for the simple fact that you've pointed it at itself as its own DNS server. What we recommend is, one, don't point a domain controller to itself as the only DNS server, not even as the primary. We recommend that you point it to another domain controller. You could bypass this check by disabling the perform initial synchronization instructions. Please don't do that. Make sure that you don't have stale DNS servers in your environment. If your DC is pointing to a DNS server that doesn't exist, you will encounter this problem. Domain controllers should be distributed across multiple data centers.
Yes, because we've talked about availability and we've talked about integrity. Now let's talk about confidentiality, because that is the third pillar of our presentation. And one of the things that we hear as a common misnomer for going virtual with domain controllers is that there's a risk of privilege escalation. And the only way to do and prevent, or the only way to prevent these privilege escalations is through implementing effective role-based access control. Now, we all know that in vSphere, you can create single sign-on with your Active Directory. And of course, it's not the most brilliant idea to have your vSphere RBAC tied up to the same domain that you use for everything else. So you could implement a second Active Directory and use that for RBAC. The other way around, though, and this is new in vSphere 7, is we can now do role-based access control. We can now do RBAC through Active Directory Federation Services, or ADFS for short. And there's two big pluses that you can achieve if you go the ADFS route. The first one is it is really easy to have your third-party MFA solution tied up in ADFS and use it towards your vSphere client and your vSphere administration. The other thing is that if you are in a constellation with multiple managed services providers or MSPs, then you can actually tie those in to your vSphere RBAC as well. And that makes sure that you have that effective RBAC on your vSphere level, just as you would on your Active Directory level.
Okay, like we mentioned at the beginning, we have this fear of the stolen VMDK, so we're going to touch on that. First, what's new in Windows Server 2016 and 2019? Well, the truth is not a heck of a lot when it comes to virtualizing Active Directory. There's two features that are worth mentioning. The first is the shielded virtual machine, which allows encrypting of virtual machines on Hyper-V. We have an answer to that on vSphere. Stay tuned for that. The other is the Windows Defender Device Guard virtualization-based security. What this does is it uses the hypervisor to protect the OS by only allowing trusted code to execute to protect against malware. That feature is available in vSphere as of 6.7. It's called the Credential Guard. And then you can learn more about it by clicking on the Microsoft link here. That'll give you all the information on how this feature works in general. But what we want to talk about is the fear of the stolen VMDK, as we talked about earlier. A rogue administrator steals the VMDK for Active Directory, and now they've got your domain database. The answer to that is virtual machine encryption. This was introduced in vSphere 6.5, and what it does is it essentially takes the entire VMDK and encrypts it so that it's unable to be taken and registered on another vCenter. Some real basic information: you can use your own KMS. vCenter really just serves as the broker and the facilitator. You don't need special hardware, although if you have it, it does improve performance. But the bottom line is, if I'm an administrator and I steal that VMDK and I try to register it on another host to get access to the domain database, they will be unable to do that because of virtual machine encryption. It's really good stuff, but we're not spending a lot of time talking about it. The good news is our peers are. We recommend you check out HCP 2047, vSphere and Active Directory Better Security Together, where they devote an entire section, an entire presentation to this.
All right, it's time to wrap things up. We've shown you all kinds of stuff during this session on time and on DNS and on domain controller cloning and VM generation ID. But one of the big key takeaways is that virtualization of domain controllers is not scary. It is fully supported. And we would love to hear your feedback, not just on Active Directory virtualization, but of course in our survey. Please, if you feel this session was worth your while, let us know. We really want to know. It gives us energy. If you want more information on VMware Cloud on AWS, then here's a link for you, and you can also take a picture of this slide. And here are some other resources to learn more. And with that, we would like to conclude this session. We would like to thank you, and we say goodbye.
Thank
Bye,
you.
everyone. Thank
Bye,
you.
everyone. Thank you.
Thank you.
See you next year.